Hello everyone, welcome to new class. Today's class is about the mesh analysis by inspection method. So in the previous class we discussed about mesh analysis. So today's class is about the mesh analysis by inspection method. So consider the network shown. So there are three loops in the network. Let I1, I2, I3 be the three currents which are in the clockwise direction and V1, V2 be the two voltage sources. So through the resistor R2, the current will be I1 minus I2, and through V2, the current will be I2 minus I3. Then we can write the general mesh equations like R11 I1 plus or minus R12 I2 plus or minus R13 I3 equal to V1, then plus or minus R21 I1 plus R22 I2 plus or minus R23 I3 equal to V2, then plus or minus R31 I1 plus or minus R32 I2 plus R33 I3 is equal to V3. So the general mesh equations can be written in this form. So here R11, R22, R33, these are the diagonal elements, and these diagonal elements are always positive. So diagonal elements are always positive and are called self-resistances. So the diagonal elements are called self-resistance. Then all other resistors, that is R12, R13, R21, R23, R31, R32, these are called the mutual resistances. Mutual resistance. So all other elements other than the diagonal elements are called mutual resistances, and they can be positive or negative. That is because here written plus or minus, and these are always positive. So mutual resistance are either positive or negative, and the self resistance are always positive. There are some procedures for the inspection method. First one is, if the direction of the loop current are not given, then assume all the currents as clockwise direction. So first one is, if the direction of the loop current is not given, then assume clockwise direction. Then second one, self resistance are always taken as positive. Then third one, mutual resistance. So mutual resistance is positive if the current through it is the sum of the two loop currents. So here through the R2 it is the difference of I1 and I2. So in that case it is negative. So if this loop current is sum of the two currents, then mutual resistance is taken as positive, and mutual resistance is taken as negative if the current through it is the difference of the two loop currents. So that is about the mutual resistance. Then next is about the voltage sources, that is V1, V2, V3. So here the voltage V1 means it is the voltage which drives the loop 1. Similarly, V2 and V3 for the second loop and third loop. And here this voltage is taken as positive sign if the direction of the current is same as the direction of the source. So the voltage V1 is taken as positive if the direction of current is same as that of the source. Then it is taken as negative if the current direction is opposite to the direction of the source. So that is about the voltages, and the voltage or EMF is assigned as positive if the loop current leaves positive terminal of the source. So these are the procedures for the mesh analysis by inspection method. Now we can write the matrix. That is, by inspection method we can write the matrix. So by inspection method the matrix can be written as, that is, the diagonal elements are R11, R22, then R33. The remaining elements are here R12, R13, here R21, R23, here R31, R32. Then into currents I1, I2, I3, then equal to V1, V2, V3. So this is the general form for the matrix in the inspection method. Now we can fill these elements according to this network. So according to this given network R11, R11 means it is the total resistance in the loop 1. So these self resistances are, okay, here the self resistances. The self resistances are the sum of the resistances in the respective loop. So self resistance are sum of resistances in each loop. So here by inspection method we can write R11 as the sum of resistances in the first loop, that is R1 plus R2. So R1 plus R2, then R12. R12 means common to the first loop and the second loop, that is R2. So write R2, then its sign. So R12 means R2, and the current flowing through R2 is the difference of the two currents, so it is negative. Then R13. So there is no resistances common to one loop and third loop, so it is 0. Then R21. So R21 is same as that of R12, that is minus R2. Then R22 is the sum of the resistance in the second loop, and that is R2 plus R3. R2 plus R3. Then R23. So R23 is common to the resistance common to the second loop and third loop, and here there is no resistances between the second loop and the third loop, so it is 0 again. Then R31. So R31 is common to first loop and third loop, it is 0. Then R32, it is same as this R23, so 0. Then R33. R33 is the sum of resistance in the third loop, and that is R4 plus R5. Then into I1, I2, I3. equal to V1. So here also we have to put signs for the voltage sources, and here V1. V1 is here positive because the current direction is same as that of the direction of the source. So it is positive here. Then V2. So in V2, I2 is in this direction and V2 is in the opposite direction. So V2 is minus V2 because EMF is positive if the loop current leaves the positive terminal of the source. So here it is negative. Then V3. Here V3, that is the voltage source in the third loop, and it is same as V2, and check whether it is positive or negative. And here the current I3 is in the same direction as that of V2. So here it is positive V2. So V1 minus V2, then V2. So this is, in this way we are writing the mesh equations in matrix form by inspection method. Now we can solve this matrix then and find I1, I2, I3 using the Cramer's rule. So this is the general form for the matrices in inspection method. Let us do a problem. Find the power lost in the 3 ohm resistor. So this is the given network. So our first step is to mark the currents. And before that, the question is to find the power lost in the 3 ohm resistor. So 3 ohm resistor means this is the 3 ohm resistor, and what is power lost? How will you find the power lost in the 3 ohm resistor? So power equations are I square R or V square by R or V into I. So here the resistance is given, and if we find the current, then we can use this equation to find the power lost in the 3 ohm resistor. So we have to find the current through the 3 ohm resistor. For that we can use the mesh analysis by inspection method, and here our first step is assuming the direction of the current. Here the direction is not given, so we can assume all the direction as the clockwise direction. So this is, let this one be I1, and here let this be I2, and this I3. Next we have to draw the matrix, and in matrix form the diagonal elements are the self resistances, and mutual resistances we have to find according to that. And R11 means the total resistance in the first loop, and here it is 5 ohm and 1 ohm. So 5 plus 1 is 6 ohm. Then next is R12, that is common to first loop and second loop, and it is 1 ohm. So here it is 1, and we have to find its sign, and for that we have to find the current through the 1 ohm resistor. So here I1 is flowing in this direction and I2 in the opposite direction. So here the current will be the difference of I1 and I2. So here it is minus 1. Then next is R13. So here the element is R13, that is common to 1 and third loops, and here there is no elements, so 0. Next is here the second row R21. So R21 is common to 1 and second loop, and here it is same as this one, so minus 1. Next is R22. So R22 is the total resistance or self resistance in second loop, and here it is 2 plus 1 plus 2, that is 5. Next is here 2 3, that is R23, that is common to second loop and third loop, and it is 2 ohm. So 2 ohm. Next, it's a sign we have to find. So here I2 is in this direction and I3 is in the opposite direction. So here again it will be the difference of I2 and I3. So here this is negative. Next is third row and here it is R31. R31 is common to 1 and 3 elements, so it is 0. Then R32. 32 means common to 2 and third loops. So it is again minus 2. Then R33. R33 this sum of the resistance in the third loop and it is 2 plus 3 equal to 5 ohm. So this is the resistance matrix. Then next is I1, I2, I3. So these are the unknown values. So we can put like this. Next is V1, V2, V3. That is the voltage matrix. First one is V1. So V1 is the voltage in the first loop and it is 5 volt. Now we have to find its sign. Here I1 is flowing in this direction and this 5 volt is positive here. So it is positive 5. Next is V2. V2 is the voltage in the second loop. And here no voltage sources, so we can put 0. Next is V3. V3 is the voltage source in the third loop and here 10 volt. Next we have to find its sign. Here I3 is flowing in this direction which is same as that of the voltage source. So it is plus here. So this is the matrix form for the inspection method. Now we can find the current. And here we need to find only the current through the 3 ohm resistor and current through the 3 ohm resistor is I3. So we have to find only the value of I3 and by Cramer's rule we can find I3 is equal to delta 3 divided by delta, where delta 3 is the determinant value for changing the third column elements with the voltage values and delta means the determinant for the resistance matrix. So here delta 3 is determinant of 6 minus 1 minus 1 5 0 minus 2. Now here these column elements are replaced with the voltage values, that is 5 0 10, then divided by delta means determinant of this matrix, that is 6 minus 1 0 minus 1 5 minus 2, then 0 minus 2 5. So here we can find the determinant using this method or using the scientific calculator, and in this method 6 into the determinant of this sub matrix, that is 5 into 10 50 minus 0, then minus of minus plus 1 into minus 1 into 10 minus 0, then 5 into this determinant, that is minus 1 into minus 2, that is 2 minus 0, then divided by again determinant and we get it 300 divided by 121 and its value is equal to 2.48 ampere. So this is the value of I3. Then we have to find the power lost. So power lost P is equal to I square R and that is equal to 2.48 square into R is 3 and we get its value as 18.45 watts. So this is the power lost in the 3 ohm resistor. So in this way we are doing the mesh analysis by inspection method. Let us do another problem. find I1 and I2. So this is the given network, and here there is one voltage source and one current source. So first of all we have to convert this current source in parallel with a 1 ohm resistor to a voltage source in series with the same resistor value. So for that the value of voltage will be I into R, and that is equal to 1 into 1 ohm, that is 1 volt. So this 1 ampere current source in parallel with the 1 ohm resistor can be converted into 1 volt current voltage source in series with 1 ohm resistor. Then the remaining elements we have to draw. It is 5 ohm resistor, then 1 ohm resistor, then here 2 ohm resistor, 5 volt. So this is the network after rearranging this current source into voltage source. And here this 1 ohm resistor in series with the 5 ohm resistor, so that we can combine, that is this is 6 ohm, then here 1 volt, and this is 1 ohm, this is 2 ohm, then 5 volt. So this is the network after rearranging this one. Now we have to consider the currents. So here the current direction is not given, so assume the current in the clockwise direction. Let this be I1 and this one be I2. And next we have to draw the matrix. So in matrix there is only two loops, so it will be a 2 by 2 matrix. So R11 is the self resistance in the first loop, that is 6 plus 1, that is 7. Next is R12, that is common to 1 and second loop, and here I1 is in this direction, I2 in the opposite direction, so the current will be I1 minus I2. So it is minus 1 here. Then in the second row it will be R21, that is same as R12. Then R22 is self resistance in the second loop, that is 2 plus 1 3. Then I1 and I2 are the unknown currents, and that is equal to V1 and V2. So V1 is here, current direction is same as that of this voltage source, that is 1. Then in the second loop here this current is in this direction and this is plus minus, so here we get minus 5. Now we can find the current. For that use the Cramer's rule, that is I1 is equal to delta 1 divided by delta and I2 is equal to delta 2 divided by delta. So I1 is delta 1 divided by delta, and that is equal to, here this first column value is changed with the values of voltage, that is 1 minus 5, then minus 1 3 divided by determinant of the original matrix, and that is equal to 3 minus 5 divided by 21 minus 1. Then I2 is delta 2 divided by delta. So here delta 2 is obtained by changing the column values of the second column values with the voltage values, that is 7 minus 1, 1 minus 5 divided by the determinant of this resistance matrix. So we get minus 35 plus 1 divided by 20. So I1 is equal to minus 2 divided by 20, and that is equal to 1 by 10, that is minus 0.1 ampere, and I2 is equal to minus 34 divided by 20, and that is equal to minus 1.7 ampere. So I1 and I2 are obtained by this inspection method, and here negative is obtained because the actual direction is opposite to what we assumed. So that is about the mesh analysis by inspection method. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.